Okay, I welcome you to this wonderful lesson actually in science class. Okay, so as you may be aware, today we are actually coming to the end of our big topic: speed, acceleration, velocity, speed time graph, velocity time graph, distance time graph. This is what we are looking at. And today we mark this topic the end. Okay, so let us go through this question and see how best we are going to move. A car moving from rest acquires a velocity of 20 meters per second with uniform acceleration in 4 seconds. It moves with the velocity for 6 seconds and again accelerate uniformly to 30 meters per second in 5 seconds. It travels for 3 seconds at this velocity and then comes to rest with uniform deceleration in 12 seconds. So question A, draw a speed time graph. B, calculate the total distance. C, calculate the average speed. So we have 3 questions under this statement. Okay, so now before we come to that one, actually I brought up this so that maybe I can give you some insight under this. So this is the speed time graph. So now when you see a horizontal line like this one, this is the symbol of a car moving. Okay, so this one now is showing that this is constant velocity or speed. Okay, there is no acceleration in the first graph. Then second, this one is a constant acceleration. From rest, it is accelerating just like that. Okay. Then the third one, constant deceleration. Okay, coming from there down to the horizontal line. Then the last graph, this is showing us that the car was actually not moving at a constant what? Acceleration. Instead, it kept on what? Changing. Yes. So now let us get back to our business. So this is actually the graph that I've drawn here. So what has just remained is to write according to the information that we have. So here they are telling us to draw a speed time graph. So first of all, for me to do this, I went back and look at the maximum velocity that we have here is 30. Okay. Remember when you are drawing the distance time graph, speed time graph, the horizontal line is consists of what? Time. Okay. Seconds. Then the vertical one is the speed or velocity. Okay. And this is what I've done. So first of all, I looked at the number of the highest velocity is 30. Then seconds again, looking at the time at which this car moved. I added all the times, then I came up with 30 seconds. So no wonder why I proceeded up to 30. Okay. Then from there now, we can start now following the statement that we have. Okay. So we are saying a car moving from rest acquires a velocity of 20 meters per second with the uniform what? Acceleration in 4 seconds. Uniform acceleration. So from rest it means this car started from here. Okay. 0. The car was resting. Then it started with the acceleration, okay, up to velocity what? 30. So we are going to, 20. So we are going to move like this, okay? Move like this. Okay, so we are here. Remember, in 4 seconds, time is here. 4 seconds, so we should not exceed that. So this line should go like this. Let me do this. Okay, so now we are going to make the acceleration like this. Okay, so that's how the car moves. In what? 4 seconds. 4 seconds. Okay, in 4 seconds. Yes, then it moves with the velocity for 6 seconds. So from there now, it just moved with velocity. For how many seconds? 6. So we are here. So here 2 plus 2, 4 plus 2, 6. So we are somewhere here. Okay? So the car now moves straight now like this. Okay? For 6 seconds. This is the velocity now. 6 seconds, it's here. Okay? Then from there, again and again, accelerates uniformly to 30 meters per second in 5 seconds. So in 5 seconds, accelerate 30 now. So now it moves up to somewhere here. It accelerates. How many seconds? 5. So we are saying here is 2, then here 4, then here 5. So 5 is here. So this one accelerate again. Okay? 30. Okay. So accelerate. Okay. For 5 seconds. That is how the car is moving. Then from there again, they are saying it travels for 3 seconds at this velocity. So 3 seconds at this velocity. So here up to there it's 1. So here is 2, so 3. So 1, 2, 3. It's here. So it travels 3 seconds. So 3 seconds here. 10 here. Okay. Then again, we are following the statement that we are given here. Okay. Then again from there, and then comes to rest with uniform deceleration in 12 seconds. So now it came to rest with uniform acceleration in 12 seconds. So 12 seconds, we have 2, 4, 6, 8, 10, 12. So from there now, direct. It decelerated. Okay. Okay, and this marks the end of this car's journey. Okay. So now from there, let us come to the second question. We have just sketched, we have drawn according to the question, that is A. Then we come to B, calculate the total distance. So now how do we calculate the total distance? The total distance actually is calculated by finding the area of each compartment. The area of this one, the area of this thing, the whole of this, that would be the total distance the car traveled. So now, so here, if you can see, we can just divide them. We have the first one, triangle. So we are going to find the area of this triangle, area of rectangle there, area of trapezium, this is trapezium, area of another rectangle, the area of triangle. Then we add them. Okay. So the answer that you are going to get, that will be the total distance the car traveled from here up to where it actually decelerated. Okay, so now we'll start. So area of the first, so I think I can name this. This will be B, A, this will be B, this C, this I think D, then this E. Okay, so we are going to add them now. So area of the first triangle, so area of this A, area of a triangle formula is 1/2BH. Okay, so now 1/2BH, let us substitute. Let us substitute breadth. What do we have? We have 4, that is times breadth, then times height is 20. Okay, so when we multiply this, we are going to have 40. Okay, we are going to have 40. So there we are going to have the area is the area of the first triangle is 20. Then we go to the next one, which is B. So area of B is equals to, this is rectangle. Rectangle, area of a rectangle is L times B. Okay. You should master the formula. You know, these are more or less like mathematics. Okay. So that's why physics is not very much different from mathematics. Why? Because there are a lot of calculations and formulas. They use same formulas. So area there is what? For rectangle is L times B. So L times B, what do we have there? What do we have? 2. We have 8 there. I mean 2, 4, 6. So length is, I'll say 6 or breadth. Let me just say 6. Then breadth there, we have 20. Okay. So 6 times 20, what is the answer? 6 times 20 is 120. Okay, so that is the area of this one. Okay, then from there we come to trapezium, which is a C. Area of a trapezium, the formula is Z, half, then A plus B, then H. Okay, area of a trapezium, so A always is the first, which is 20. Okay, 20 plus B is always that one, which is 30. Then H is this one. 1, 2, this is 2, 4, 5. Okay, so times 5. So half, this plus this, we are going to have 50 there, times 5. So half times 50, that is 25. 25 times 5, it's 125. 125, yes. So for this one, 125. Again, we come to this one, which is, this is our C. Which side am I going? Let me rub on the top there. The space is just too small. So we can rub on top and use it to finish the question. Okay, so we are on now D. Okay, D, that one is a rectangle. Okay, so the area of this rectangle times B. So L there, our L, we can say that one. So we say this is 3. Okay, 3 times the breadth, we'll get that one, 30. Yes. Then when we multiply this, what are we going to have? 90. 30 times 3, that is 90. Then we go to the last one, E, that is a triangle, BH, half, 1, that is 2, 4, 6, 8, 10, 12. Okay, so we are going to say breadth 12, then times what is our height is 30. Half. So let me just say 2 into 12 there is 6. So 6 times 30 is 180. Okay. So now the total distance according to the question is equals to A plus B plus C plus D plus E. So when we add this, what are we having? A is what? 20 plus B is what? 120 plus C is 125 plus D is 90 plus 180. Okay, so since calculator is allowed, we can use a calculator here. 20 plus 120 plus 125 plus 90 plus 180 The answer is 1, or I mean 535. 535. That is our answer. That is the total distance. Total distance. Okay, yes. So here, actually, on the A, the first one, we made a slight mistake there, where we said 4 times 20 is 80, not 40. So half of 80 is 40. Okay, so we are going to add now. So here, it is going to be 40. Okay, so 40 plus 120 plus 125 plus 90 plus 180 is 555 meters. Okay, so that was the total distance which that car covered. Okay, now we go to the last part of our question. Calculate this average speed. So average speed or distance over time taken. Okay, so distance we have is 345. Over time we have is 30 seconds. Okay, so now from there we can say 345 divided by 30. The answer is going to be 18.5 meters per second. Okay, so this is how we answer such type of examination questions. Thank you so very much for your attention.